Hello everyone, welcome to my YouTube channel. So here we are going to start a lecture series on the topics of mathematics syllabus of class 11. So I will be starting with chapter 1 of class 11 mathematics, that is sets. So in this video we will be discussing all the prerequisites and introduction regarding sets which are required for doing the exercise 1.1. So hope you all will enjoy this video. First of all, let us see what is a set. Before going to the definition of a set, let me introduce set using different examples. So first example is that here we can see a pack of cards. I believe that all of you are familiar with pack of cards. So if I am saying any one of you to take a pack of cards, then all of you will be taking the same set of cards, right? The total set of cards everyone will be taking. All over the world, the pack of cards means the same, right? Okay, let us move to the second example. If I tell to all of you to write the names of the best Indian cricketers, then what will be your answer? So every one of you will be having different answers. For some, Mahendra Dhoni, Virat Kohli, they will be the best Indian cricketers. For someone else, it will be Dravid and Sachin. So it varies from person to person. But the first example was the same for all. But the second example, it varies from the choice from person to person. The third example is if I tell to you to write the vowels in English alphabet, then everyone's answer will be the same, which is nothing but A, E, I, O, U, right? In the fourth example, if I tell to you write the names of the beautiful girls in your class, then will the answer of every student be the same? Exactly no. Because the beauty is defined in different terms based on each person. For someone, beauty will be based on the eyes. For someone, beauty will be based on the texture of the hair of the girl or the length of the hair and so on. So the answer given by the all the students of the class will not be the same. So, what did you understand from these four examples? So, these four examples are nothing but we are taking a collection of something, right? A pack of cards means it is a collection of cards, and the pack of cards is the same in all over the world. Okay. The second one was a collection of Indian cricketers, but the choice made by each person differs based on their favoritism. But the third set collection, which was the vowels in English alphabet, it will not vary from person to person. Everyone will be giving the same answer, which is nothing but A, E, I, O, U. Clear? And the fourth example, it also varies. It is a collection of girls in your class, but the answer, it varies from person to person. Thus, we have observed that there are certain collection of objects which will remain the same throughout the world without any change. That is the pack of cards and the vowels in English alphabets. At the same time, there are some collection of objects which vary from person to person. Clear? Or in other words, we can say that if we are given an object, if we are given an object, then we can easily say that the object belongs to this collection or not. Clear? If I am giving a flower to you, then I can easily say that this flower does not belong to this collection, right? Okay. Clearly, if this is the collection of best Indian cricketers, and if I am giving the name of Ganguly, then I am not sure that whether Ganguly belongs to the collection of best Indian cricketers or not, right? Because I am not sure that whether any student have selected the name of Ganguly as the best Indian cricketers. So here we cannot say thoroughly whether a given cricketer belongs to this collection or not, right? But here, if I am given any English alphabet, say I am given B, then clearly I can say that this B does not belong to the collection of vowels, right? And if I am given A, then I am clearly done that this A belongs to this collection. So here we are clearly able to say whether a given alphabet belongs to the collection or not. Now, in the fourth example, here also, if you are given the name of a girl of your class, we are not sure that whether the name of that girl belongs to the collection or not, because we are not sure whether any student have written the name of that particular girl or not. Clear? So there are some collections which are uh, well defined, and this term which we used now, it is called the well defined. That is, we are able to say whether a given object is in that collection or not. But these two sets, the set and the collection of best Indian cricketers and the collection of beautiful girls in your class, they are not well defined. So now we are in a position to give the definition of a set. So here is the definition. Let me erase all these things. Okay. So what is meant by a set? A set is a well-defined collection of objects. So here the term to be stressed is well defined. Well defined means we are able to say whether a particular object belongs to that collection or not. So here is the definition of well defined. Well defined means if we are given an object, then we will be able to say whether that belongs to the given collection or not. Clear? The another term to be stressed is objects, collection of objects. So what particular objects are considered here? Here there is no specification for the objects. It can be anything. So that is the definition of objects. See, here in the definition of set, the objects taken can be anything in this universe. Clear? So I believe the definition of set is clear to you. A set is a well-defined collection of objects. So in the previous example, the pack of cards, it was a well-defined collection of objects, so hence it is a set. But the collection of best Indian cricketers, it is not well-defined because we are not sure whether a given cricketer will belong to that collection or not. So it is not a set. But the collection of vowels in English alphabet, it is well defined and hence it is a set. The fourth example, which was the collection of all beautiful girls in your class, it is also not well defined because we are not sure whether a given girl in your class belongs to that collection or not. Hence, the fourth example is also not a set. Is that clear? Now, the theory of sets was developed by the German mathematician Georg Cantor. He was the one who introduced the concept of sets. Okay. Now, we will see some particular sets used in mathematics. So, the first one is this notation we are using, N, capital N, which is in bold. It represents the set of all natural numbers. Yeah, what is meant by a natural number? The numbers starting from 1, they are known as natural numbers. 1, 2, 3, etc. This is the first set. So it is also a collection of objects, and we are able to see that whether a given number belongs to this set or not. We are clearly able to say. So it is a well-defined collection and hence a set. The second one is Z, which is the set of all integers. What are integers? The numbers which are the natural numbers, then 0 and the negative of natural numbers. They constitute the set of integers. Here, all the negative numbers, 0 and then the positive numbers. So this is the set of all integers. The third one is the set of all rationals. So here, the set of all rationals, here an S is missing, rationals. Okay. What is meant by a rational number? A rational number means it is a set of the form P by Q, where P and Q are integers and Q not equal to 0. So this is the definition of a rational number. So any number of the form P by Q with these conditions are known as a rational number. So here we are taking some examples. See, 1 by 2, it is a rational number. Minus 3 by 1, it can be written also as minus 3, right? Then minus 3 is an integer and also it is a rational number. 7 by 5, etc. All these are examples of rational numbers. So here the specialty is that the set n of natural numbers, it is fully contained in the set of integers. The set of integers is fully contained in the set of rational numbers. And now comes the next bigger set, which is R, the set of all real numbers. So all rational numbers are contained in the set of real numbers. So the real numbers are constituted together with rationals and irrational numbers. Irrational numbers are those which cannot be written in the form P by Q. Example, pi. Pi is an irrational number. E, exponential E. It is an irrational number. Okay. And this is the biggest set of numbers which we know till now. Okay. I mean till your 11th class. In the next grade, 12th class, you will be learning about somewhat more bigger set, which is the set of complex numbers. Okay. So here at present, we are dealing with only up to the real numbers. And other notations are Z plus, which is all positive integers. Positive integers means they are nothing but the natural numbers itself. And then the other notation for the set Q plus, it is the set of all positive rationals like 1 by 2, 3 by 1, 7 by 5. Negative numbers are not included. Okay. And the last one is R plus, which is the set of all positive real numbers. And the examples are root 2, 7 plus root 2. Root 2 is an irrational number because it cannot be written in the form P by Q. And 7 by 5, it is a rational number. 5 is an irrational number. 6, it is a natural number and hence a real number. Okay. So these are the notations which are used for some particular sets used in mathematics. And these notations we will be using throughout our lecture. Now we will see some of the important points to be noted while dealing with sets. The first point is that in a set, the objects, they are also called elements or members of the set. Other names used for objects are elements or members of the set. Usually, a set is denoted by capital letters like A, B, C, or any capital letter you can use for representing a set. At the same time, the elements of the set, they will be represented by small letters like small a, b, c, x, y, z, etc. Clear? Now, if we are having a set capital A and small a, it is an element of the set capital A. then we say that A belongs to capital A. Now, how we will use a notation for that? So, this is the symbol which we are using for this, and it is read as A belongs to capital A. And this is a Greek symbol known as epsilon. We are using this symbol to represent the concept of belongs to. Clear? And at the same time, if B, it is not an element of the set A, then we use the notation B belongs to A, and we are putting a cross on that symbol. And it is read as B does not belong to A. Clear? Let us see this through an example. Let capital V represent the set of vowels. Then we know what all elements are there in the set capital V. A, E, I, O, U. Clear? Then if you are taking A, then it is belonging to the set. Then it is giving, or we are giving the symbol A belongs to V. But if you are taking B, then it is not in that set. Then how we will represent it? Like this, and it is read as B does not belong to capital B. So these notations will become very common throughout our lecture, and also in the coming lectures also these notations are very useful. Next, we are dealing with the concept of representation of a set. How can we represent a given set? Now, till now, we have learned what is meant by a set, and then we have learned some examples of sets in mathematical concepts, and then we have learned some important points which have to be taken care while dealing with set. And now, a set can be represented in two ways. There are two methods of representing a set. The first method is the roster form, and the second one is the set builder form. So we will be dealing in detail with both these methods. So first, let us look in detail about the roster form. So here is the definition. In roster form, all the elements of a set are listed. See, I will be showing you. Let capital V or capital A, whatever name you can give, be the set of vowels in English alphabet. Then how we will we represent this set in the roster form? So here it is given all the elements of a set are listed. First, we have to list all the elements. A, E, I, O, and U. These are the elements. Okay, we have listed the elements. Then what is the next step? The elements are being separated by commas. Then we have to separate these elements by commas. Okay, I'm separating this with comma. Okay, and then and are enclosed within the braces. This curly braces, we have to enclose them. Okay, so I am enclosing it. So this is the representation of the set of vowels in roster form. It is very simple here. So first the elements should be listed, then the elements should be separated by commas, and then they are enclosed within braces. So is this clear? So this is how we will be representing the set of vowels. Okay, let me write it. Okay. The set of vowels in English alphabet is written as. So I can give a name to the set. It can be any capital letter. Clear? It is up to you. Now let us consider a second example. The set of odd natural numbers. Odd natural numbers means 1, 3, 5, etc. And it is going on, going on. It is not ending, right? Then how we will represent such a set which is not ending? It is having infinitely many elements. Then first we will be listing some of the first 2 or 3 elements we will be listing, and we will be separating them by commas, and then we will be putting 3 dots to represent that the set contains infinitely many elements, just 3 dots. Okay, and then we will be enclosing it within the braces. So that is how we are representing a set with in roster form, which contains more elements, which cannot be, which never end. Okay, fine. The next point to be noted while writing in roster form is that the order in which the elements are listed is immaterial. That is, in roster form, there is no order for any element. The element which is written in first, it can also be written in last, or the element written in second last. Oh, it can be written here in the first also. Okay, for example, see the set of vowels, it can be written like this or this or this or any way we can arrange the elements. So all this represent the same set. So in roster form, the order of the elements are not of that much importance. Clear? Fine. The second point to be noted is that in roster form, an element is not generally repeated. We never repeat an element. That is, for example, in the set of vowels in English alphabet, here, if we write A, E, I, O, U or A, E, I, O, U, if I write an element two times, then it is not valid in roster form. In roster form, one element will be written only one time. Okay. Let me give an example for this. See, the set of letters, I'm writing a set which consists of those letters which constitute the word school. So what all are the letters? S, C, H, O, L. So here, if I'm writing the letters in this word as a set, then here O is coming two times, right? But if you are writing in roster form, then we will write O only one time. One element has to be listed only one time. There is no need to repeat it. So these are some points which should be taken care while writing a set in the roster form. Is that clear? So this is all about the roster form. The next representation of a set is by the method of set builder form. So how is set builder form written? So here, okay. The definition given here is in set builder form, all the elements of a set possess a single common property which is not possessed by any element outside the set. That is, in order to write a set in set builder form, the thing which we should need is that the all elements of that set should possess a single common property which is not possessed by any element outside the set. Clear? For example, if I'm taking the set V of vowels, okay, which is how we will write it in roster form as A, E, I, O, U. First listing, then separating by commas, then we are enclosing them within the curly braces, right? So this is the set of vowels in roster form. So how we can write this in set builder form? Set builder form here, first we should find a common property which is possessed by the elements in this set. What are the common property? They are vowels in English alphabet, right? If you are taking any element outside this set, say B, then this element is not possessing the property of vowels. Clear? So once we identify the common property of the elements of this set, how we are writing is that we are starting with curly braces, okay? Then we are representing elements of the set by a general element, say X. We are giving a common name for all the elements of the set. Then we are using this symbol of colon. We are putting colon, which means double dot. Okay. Then we are writing the common property possessed by the set, which is X is, sorry, let me erase that. X is a vowel in English alphabet, right? English alphabet. So if you are writing this and then enclosing the braces, then this is the set builder form. Okay. So how we are writing in set builder form? Starting with curly braces, then we are taking all the elements as a general element X, then colon, and then we are writing the common property. Clear? So this is set builder form. So in set builder form, the most important thing is that we should find a common property possessed by the elements of the set, which is not possessed by any element outside the set. So here is the general form of set builder form. Set of all X, and this colon is read as such that X has, and then we write the common property. Let us see some examples. So the first one is the example which I illustrated now, the set of vowels. The set of our X such that X is a vowel in English alphabet. Clear? So let me take other example, which here this set we introduced in the roster form, right? What was the common property possessed by all the elements of this set? They are odd natural numbers. So we will write it as, we can give any capital letter name to the set. I am giving capital A equal to, how it is read? Set of all. This curly bracket we are reading as set of all X, and colon is written as such that X is an odd natural number. Here, okay, let me take one more example. If you are given the set 2, 3, 4, 5, 6, so this is given in roster form. So we have to write it in set builder form. How we can write? See, first we have to observe what all properties these elements are having. So here we can say that 2, 3, 4, 5, 6. So all the elements between 1 and 7, natural numbers between 1 and 7 are given, right? So how we'll write? Set of all X such that X is a natural number, or we can write it in sentence that X is a natural number, or we can use this notation which we learned previously. Okay, X belongs to, and this is the symbol for the set of natural numbers. X belongs to natural numbers, comma, and one more property. What is that? 1 less than X less than 7. That is, all the elements belong to the set between 1 and 7 of natural numbers. Clear? So this is how we can write a given set in set builder form. Thus, a set can be written in two ways. One is roster form and one is set builder form. So these are all the prerequisites which are needed to solve exercise 1.1. Hope you have enjoyed the video. If you have liked the video, then subscribe my channel and share this video to all the students who are studying in class 11, and of course like my video. Thank you. Have a nice day.